Welcome to section 5.4 of the Intermediate Algebra online video lecture series by Dr. Scott Franklin. In this section, we are going to talk about factoring trinomials. Now, we factored in the last section by grouping. Now we're going to take an approach for how we factor polynomials that have 3 terms. In general, if your number of terms is bigger than 3, you're always going to try grouping. But when you have 3 terms, there's a special strategy that we're going to go through in this particular section. To begin with, we're going to factor a trinomial when the leading coefficient is 1, because that strategy will help us when we move into more complicated situation, and that's when the leading coefficient is something other than 1. Now, once we've learned how to factor trinomials, we're going to employ another trick to handle even more polynomials using a technique known as substitution. Before we jump too far into factoring trinomials, I want to show you something just as a reminder of what happens when we multiply 2 binomials together. You'll remember the technique that we learned back in section 2 of chapter 5 called the FOIL technique, or what I affectionately refer to as the monkey face method. But if you had something like x plus 2 times x plus 10, the FOIL method says you take the first 2 and multiply them together to get x squared. In fact, let me do this, move that down just a hair. Put an x squared. Okay, and then the outside, which is 10x, would add together with the inside, which is 2x, to give me 12x. And then the lasts together, 2 times 10 gives me 20. Notice the result of multiplying binomials of this similar form give me a trinomial as a result. Okay? What we're going to want to try to do is, instead of going this direction that we just went by multiplying out, we're going to try to reverse the process and end up with the factored form instead of multiplying them out. So the real question is, how do we figure out what goes inside the binomials when we start with a trinomial? So let's start with trinomials of this form, that is, where the leading coefficient is 1. There's nothing else in front of there. Okay, so what we know from that is that the first 2 terms, if they multiply together to give me x squared, that the factoring result is going to have an x here and an x here. So when it's of this form, when there's a 1 in front of the x squared, really the only thing we got to figure out is what goes in the second places here. Okay? Now, recognize what we know. The last term here came from the lasts multiplied together. So we know that whatever goes here and whatever goes here have to multiply together to give me c. But there are more than one pair of numbers that multiply together to say give me 20. Right? 4 and 5 would multiply together to give me 20, but 4 and 5 is not the factored form here. So we've got to consider every possible pair that multiplies together to give me that last number. So we're going to find pairs of numbers. I shouldn't say numbers, I should say factors, meaning 2 numbers that multiply together to give me something. Find pairs of factors for the constant term c. And we're going to try various combinations of these factors, and we're going to select the combination in which the sum of the outside and the inside products is equal to bx. So we're going to take x and we're going to stick something here. We're going to have x plus, we're going to stick something here. We're going to check that the outside, right, that's the O, and the inside, the I, that when they add together, I get bx. That's I plus O. And of course they have to multiply together to give me c, but that's what we're getting from step 2. At which point then we're going to check our work by multiplying the factors out using the FOIL method to make sure that we're correct. We should obtain the original trinomial. If none of the possible combinations, if none of the pairs of factors of c will give us an outside product and an inside product that add to give us b, then the trinomial cannot be factored using integers, and it's called a prime polynomial. Now let's do an example. Let's use these steps to factor this trinomial here. Again, we know a trinomial is going to factor into two binomials, and because the first term is x squared, the firsts have to be x times x. Now we're looking for two things that multiply together to give me 24. So I'm going to come over here and build a little tree and list every possible option. 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Okay? So let's try different pairs and see what we get. What if I tried, say, the last one? If I did plus 4 plus 6. Okay, check the outside and the inside. Okay? The inside gives me 4x, the outside gives me 6x, which adds together to give me 10x. Is 10x the middle term? And the answer is no. So that is, in fact, a wrong answer. That doesn't work. So we tried that combination. Now I'm going to strongly suggest that when you're doing this on the notes, when you're doing this with your homework and you're working problems on your own scratch paper, it's probably best to use a pencil, because what I will begin to do as I do this on the screen is erase and try the next number. Erase and try the next number. This is called a trial and error method of factoring. So try the next one. X plus 3 and x plus 8. The outside gives me 8x, the inside gives me 3x. They add together to give me 11x, which checks out, which means that is my factored answer. Right? The final answer is x plus 3 times x plus 8. And if you multiply that out, you'll see that that checks. And that is how we factor a trinomial of this form. Now, one of the things that we need to be aware of is we got to make sure that our signs match up correctly. Meaning that if I had x squared plus, what we did in the last example, I'll just do a quick one of that. Plus 11x plus 24, and if I had x squared minus 11x plus 24. Right? The problem with factoring these is we've got to make sure we get the signs correct. Now we just saw that x squared plus 11x plus 24 factors into x plus 3 and x plus 8. Now, because 3 times 8 gives me 24. Now how would I factor this one? Notice that the outsides would have to add together to give me a negative. Right? But they have to multiply together, the lasts have to multiply together to give me a positive. Now how can I get two things to add together to be negative but multiply together to be positive? Well, what you remember is that when two things multiply together give me a positive, they just have to be the same sign. Right? They don't have to be, they can't be opposite signs, they have to be the same signs. They can be both positive or both negative. So what you see here is that x minus 3, x minus 8 would work there, because you'd get a minus 8x and a minus 3x, which would give me, added together, a minus 11x. So that works. Okay. Now what happens if, for example, the last term is negative? How do you get a negative at the end? The only way for that to happen is if you have different signs. Right? That would have to be something like this. X minus 3, x plus 8. Where they have opposite signs, and you got to check and see, does that work? You get 8x and a minus 3x, which add together to give me the 5x. So that would be how we factor this one. So these three concepts put together give us what's called the sign test. And here's what we use. If the sign of the last term is positive, then check the middle signs. Then the middle signs are the same, and you check the other sign to tell you which. Right? When you're factoring, if this is positive, you know they're either both plus or both minus. And the way you tell which one it is by looking at the other sign. If the last term is negative, then the middle signs have to be different. Now, how do you know which one's which? Well, you try it. If it doesn't work, You get the wrong answer, you switch them. So you've actually still got to do a trial and error there. But you know that they're different. Let's do an example. I don't have it typed in your notes, but write this down. It's going to be a squared plus 5a minus 14. Let's try our technique for factoring a trinomial on this. Our coefficient at the beginning is 1, so we know the first two have to multiply together to give me a. Now check the sign. What does that minus sign tell me? Well, if the last term is negative, then the middle signs are different, so plus minus. Now what are my choices for numbers that multiply together to give me 14? 14 can be 1 times 14 or 2 times 7. Let's try 2 times 7 and see what we get. The outside gives me negative 7a. The inside gives me 2a. 2a added to negative 7a is negative 5a. Is that right? The answer is no. It's wrong. It's the opposite sign, right? Well, try switching your signs then. That's what you do if you get the wrong sign, is you just switch them. Make this minus, make this plus. That becomes a plus 7a and a minus 2a, which is plus 5a. So that works, which means this is how that trinomial factors. Okay, next one. Let's do this example. We've got 4y cubed plus 12y squared minus 72y. Now we have not had to apply this rule yet, but from now on, remember when factoring that before you do anything else, like trying to factor a trinomial, pull out the GCF. First thing you always do is pull out the greatest common factor. In the previous examples, if you go back and look, you'll notice that none of them had a GCF, and I chose that on purpose. Now we're going to have check that. Does this have a GCF? Is there a number that goes into 4, 12, and 72? And the answer is yes, 4 goes into all of them. What about y's? Do you have a y in common? Yes, they all have at least one y. The lowest power y you see is to the first. If you pull that out, you see what's left behind. Taking a 4y out of 4y cubed leaves a y squared, because they multiply together to give you 4y cubed. Taking a 4y out of 12y squared leaves me with plus 3y. And a 4y out of negative 72y is going to leave me with a minus. 4 goes into 72 18 times, and the y comes out. Now we're going to try to factor the trinomial that's left inside. And it is of the form where the coefficient is, leading coefficient is 1. So I'll put a y in each place. This minus sign tells me that they are opposite signs. I'm going to try my different values that multiply together to give me 18. I got 1 and 18, 2 and 9, 3 and 6, 4, 5. That's all that goes in there. So let's try 3 and 6. See what we get. That's a negative 6y. The inside is 3y. Adds together to give me negative 3y. But it's positive, so I need to switch my signs. Make this minus and make this plus. So that's plus 6y minus 3y gives me plus 3y. So there it is. That is now completely factored. Alright, so remember that. Always pull out the GCF before you do anything else, and then follow the same strategy as before. Alright, now let's take it the next step. What about trinomials where the first coefficient is not a 1, but maybe something else entirely? The strategy is going to be similar, except we've got more possibilities. Let's assume for the moment that there is no greatest common factor, because if there is, we'll pull it out. And so there's nothing in common to all three of these terms right now. What you're going to do is you're going to find two first terms whose product is ax squared, right? Which means you're going to find something to put here, something x times something x, right? That together is going to give me the ax squared part of my answer. Then we're going to find two last terms whose product is c. So we'll have this have filled in there. We'll find something else to go right there. We'll find something else to go right here. And the lasts will multiply together to give me the c. So ax squared plus bx plus, and it will give me the c. By trial and error, perform the steps 1 and 2 until the sum of the outside product and inside product matches the middle term. If no such combination exists, the polynomial is called prime. Alright, let's do a couple of problems using that strategy. First of all, is there a GCF here? Well, 19 is a prime number. It doesn't have anything that divides into it except itself and 1, so it can't have a GCF then. They don't even all have an x. This one doesn't have an x in it. So now let's set up our answer. Now we've got to look at the first and the last. Okay, what two things multiply together to give me 6x squared? What are my choices for the firsts? Well, I could use 6x and x. I can use 3x and 2x. Okay, what about a choice for the 15? All right, I've got 1 and 15 and 3 and 5. Now I've got to be able to try these not only in the order I have here, but every possible order. Okay, so let's try 6x and x. What's the middle sign going to be? Well, this tells me they're the same, and this tells me then that they're both plus. So let's try our different choices over here. Okay, now 1 and 15, that's going to be huge, right? 15 times 6 is a large number. Plus x is way bigger than 19. I'm not even going to get my calculator out to figure that one. Alright, so what about 3 and 5 or 5 and 3? 3 and 5, the outside gives me 30x. The inside gives me 3x, which adds together to give me 33x. So that doesn't work. So take that out. We'll take these out. And try again. What about 5 and 3? That's 18x on the outside and 5x on the inside, which adds together gives 23x. So that also does not work. So what I've tried is 6x and x with every possibility over here. Almost every possibility. I didn't try 15 and 1. So the trial and error, again, you need your pencil to do some erasing back and forth if you got to. Sometimes you'll get lucky and it'll happen on the first or second try. Other times it gets a little bit harder. This is 15x here. This is 6, which gives me 21x. Still doesn't work. Alright, so I've ruled this out. That doesn't work. 6x and x doesn't work with any of the possible combinations with the other side. Okay. Alright, let's try 3x and 2x then. 3x, 2x. So let's try 1 and 15. That gives me on the outside 45x. That's huge. That's going to be too big, so that can't possibly be it. So let's try 15 in the middle here, and 1 out here. That's 30x and 3x. That also doesn't work. So at this point I've actually ruled out this as a possibility because it can't be 1 and 15 or 15 and 1. What about 3 and 5? That's 15x and 6x adds together to give me 21x. Nope. Beginning to wonder if we're going to get there. Oh, sorry about that. Last try. All right, what have we got left? We got 5 and 3. Okay, that's 9x on the outside. 10x on the inside adds together to give me 19x, which is what we're looking for. Woo-hoo. We did it. We got there. Now, if that had failed, the last one, we would have said this is a prime polynomial. But it didn't fail, it worked, so we were able to factor it. Now, almost always, you won't get down to the very last try. You'll be able to get there sooner than that. But I wanted to do that to illustrate just how long sometimes this can take with the trial and error method. That's the way that it works. Okay, last one of these examples. Nope, we got two more, in fact. Let's try this one. First of all, what's the GCF? I cannot pull out a number, but I can pull a y cubed out of all of those, and I'm left with 10y squared minus 17y plus 3. Now I'll factor what's left behind. Okay, for 10y squared, I have 10y and y. I'll have 2y and 5y. And for 3, I can only do 1 and 3 or 3 and 1. Now, this being a plus tells me that they're the same sign. This being a minus tells me they're both minus. So let's try 2y and 5y. And let's try 1 and 3. The outside gives me negative 6y, the inside gives me negative 5y, which adds together to give me a negative 11y, which doesn't work, so let's try switching the 1 and the 3. I get on the outside a negative 2y, and on the inside a negative 15y, which adds together to give me a negative 17y, which is exactly what I'm looking for. So there we go, factored in final form. Again, we need to check on this example to see if there is a GCF. And there is, because a number can be pulled out that's common to all of those. The largest number that divides into 12, 10, and 8 would be 2. Okay, if I pull out a 2, I'm left with 6x squared. And I can't pull out an x because this term doesn't have one. And I can't pull out a y because the first term doesn't have one. Pulling out the 2 leaves me with 6x squared plus 5xy minus 4y. These don't have, or 4y squared. These don't have a common factor, so we know we've got the biggest one out. So let's try our factoring. First of all, this sign tells me that there are opposite signs in here. 6x squared, two things multiplied together to give me that would be 6x and x, 2x and 3x. The 4y squared would be 4y and y and 2y and 2y. So let's try 2x and 3x, 4y and y. The outside gives me negative 2y. The inside gives me, 2xy. The inside gives me 12xy. 12 minus 2 is 10xy, which checks out. Right? No, it doesn't check out. It checks out with this problem, but we're actually trying to factor this one now, right? We're trying to get to 5xy. So that does not work. So we got to erase it and try the other way around. Let's do a 4y here and y here. So y and 4y. The outside gives me (2x times minus 4y is minus 8xy). The inside is 3xy. So 3xy and a minus 8xy is minus 5xy. Alright, we're close. We've got everything right, but the sign, if that's the case, then just switch the inside signs from plus minus to minus plus. So the outside gives me plus xy, 8xy. The inside gives me minus 3xy. Adds together to give me a plus 5xy. And there we go, completely factored. The reason I threw in this example here is so that you could see that our second or our last term could also have another variable in it, and we'll still be able to factor it. Now, I don't know if you noticed this, but in every one of the examples that we did, the factoring, the trinomials, the first term was a square, the second term was a first power, and the last term had no variable at all. Or one of the variables went from square to first power to none, while the other variable did just the opposite, like in the last example. But in every case, it was squares that we were dealing with. Now, it's possible that you might run into a problem like this, where at first glance, it doesn't look like we'll be able to factor it, but with a quick little trick, we're going to be able to factor it just like we did with the previous examples. In this case, notice if I have 2x to the 6th plus x cubed, 13x cubed plus 15, x to the 6th is going to throw things off. But if I choose a new variable, let's call it t, and I set that equal to this guy right here, x cubed, notice that this right here, x to the 6th, is the same thing as x cubed squared. I can just rewrite that problem like this. I have a 2x cubed quantity squared, because x to the third to the second is to the 6th. 13x cubed is exactly what we had there to begin with, plus 15. Notice this is just t, and this is just t. So this is the same thing as 2t squared plus 13t plus 15. Now it's just a square that we can factor the old-fashioned way, right? What we do is we figure out what multiplies together to give me 2t squared, which has to be a 2t and a t. This plus sign tells me the two signs are the same. This plus sign tells me they're both plus. And then I need to try things in here that multiply together to give me 15. If I try 3 and 5, I think that works. 2t times 5 is 10t. 3 times t is 3t. Add together to give me 13t. There we go. That works. But that's not the final answer because the original problem had x's. So then you're going to let t be x cubed again, and you'll have 2x cubed plus 3 times x cubed plus 5, and you will have factored something that has x to the 6's in it. So the trick is to find a good substitution that turns it into a factoring problem that involves only squares. Then factor it and plug your substitution back in. Look at this next example and see if you can't figure out what would be a good t, a good variable to let t be equal to. Well, I suggest we use the same thing we did before. Take the middle term. What's the variable part of the middle term? It's z squared. And notice I can write z to the 4th as z squared squared. And that's just z squared in the second term and minus 14. There's my t. There's my t. I now have 3t squared plus t minus 14 that I can factor as I have before. We know the first have to be 3t times t because they multiply together to give me 3t squared. This sign is minus, so they're opposites. Now 14 is 1 and 14 or 2 and 7. If I try 2 and 7, that doesn't work. With a quick eyeball check, I get negative 21 plus 2. That's not going to work. So let's try 7 and 2. That's negative 6t and a 7t. Add together to give me a positive t, so that works. And then substitute back in. T is equal to z squared, so the final answer would be 3z squared plus 7 z squared minus 2. That's how we factor by substitution. It's the same strategy as before with the added step of converting it into a problem that matches our criteria. Alright, that's the end of factoring trinomials. The last factoring we're going to do are going to be special factoring formulas, and those generally will work when we have two terms. Instead of trinomials, we're looking at binomials. We need special factoring formulas to cover that. So that's the end of section 5.4.